Okay, see if you can do this one now. We are now on Pluto. We're going to fire a cannonball vertically upwards at 9 meters per second. Gravity on Pluto is 0.58. So if you think about it, Jupiter is 23.12. Earth is 9.8. The Moon is 1.622. So Pluto must be tiny. Well, the gravity on there is only 0.58. Okay. Well, anyway, when we fire a cannonball, it will come to a stop and then it will fall back down again. Find out the height after 20 seconds. Okay. So find out this height here after 20 seconds, and also find out the time of flight. The time of flight is a time that it stays in the air. So it's up here and all the way back down here. How long? The time of flight is the time it stays in the air. So start and then stop down here. Okay. So find out two things: the height after 20 seconds and the total time of flight. Okay. In the past I would ask you to find out the maximum height and then jump to the free fall formula, which is h equals gt squared over 2. But now in the previous video I showed you a new technique where you can just use the trapezium rule. So even if it's on a negative side, who cares? You just get this height and then add it to this height and then divide it by 2. That will give you the average of the two, and then you times this distance. So learn to work out the area by using the trapezium rule rather than this one. You see, when we first started out, I wanted you to do this so that you could see what's going on. But now use this technique. It's much more efficient. Okay. So remember, find out the height after 20 seconds and find out the total flight time. So press pause and have a go. Okay, so in order to do this, jump to your velocity time graph. So your velocity time graph will look like this: velocity time graph, and the gradient won't be steep because this thing here is really small. The gravity is really small, so the decline is tiny. So it's going to be really shallow, something like this. Okay. Something like that. It's going to be shallow. The gradient will be shallow. Anyway, this here would be 9. Okay, the intercept here will be 9. So we need to come up with a formula for this line here. Any straight line will be in the form of y equals mx plus c. So in this case, the gradient is negative 0.58 x plus. Well, the intercept is 9. So now tidy everything up. So the formula for this line would be v equals 9 take away 0.58 t. Okay, so this is our magical formula here for this line. Well, what do we need to find out? Normally we need to find out the time of maximum height. You see, the time of maximum height, if you want to find out the total flight time, it will be 2 times the maximum height. Just accept my word on that, because just accept that the time it takes to get to the maximum height will be the same time as it takes to fall back down to well, I can't say back down to Earth, but back down to Pluto. So here the time of flight here is this point here. So set the v to 0 because at this point here the velocity is 0. So put 0 into the v. So this will be this 5t, and then add that thing to both sides. So it will be 0.58t equals 9. So t will be 9 over 0.58, and then you would jump to your calculator. Hang on, calculator. Okay, this one here. So it would be 9 divided by 0.58 equals 15.52. 15.52. So this time here is 15.52 0.52. So the time of flight will be double this. So it would be so this would be plus by itself. So this will be 4, 0, carry the 1, so that's 1, 2, 3. So it would be 31.04. Okay. So the total time of flight would be this. Okay. It would be at this point here. But the question is saying find the height after 20 seconds. So well, if 31 is this mark here, okay, 20 I'm gonna guess around here somewhere. Okay. So we want to find out well, it's going to be in effect this area. Merge this area with this area. Now this small area here is tiny. It represents the distance on the way down. Okay, so who cares? We're just going to use a trapezium rule, but we need to know this height and we need to know this height here. Well, this height here we don't know what it is, but we need to know it. So we're just going to put, well, don't forget at this point is 20. We're just going to put 20 into this formula here, and then this v here will take us to the height here. It should be negative, but let's put 20 into here. So now we are trying to find this height here. The reason why we need this height is because we're going to use the trapezium rule. So it's going to be this plus this divided by 2 and then times 20. Okay, but we need to know this height first. So let's try and find out the height. So we're going to put 20 into the formula. So we started with v equals 9 take away 0.58t. Now we're going to put 20 into t. So the v here would represent this height here. We need that height. So 9 take away 0.58 times 20. Okay, because 20 goes into the t. So now jump to the calculator. Hang on, clear. 0.58 times 20 equals 11.6. So 9 take away 11.6. That will equal clear. 9 take away 11.6 equals negative 2.6. Okay, so this height here is 2.6. So who cares? I'm just going to get this height plus this height divided by 2 and then times 20. That will give me the sum of the two areas. Okay, so sum area. I'm just going to say area equals what was it? Equals this height here, which is 9. Okay, 9 plus this thing here. Okay, plus that thing there would be this here, and then divided by 2 will give us the average, and then we need to times 20 because this whole length here will be 20. It's just like the trapezium rule here. If you want to work out the area of this, you would get this plus this divided by 2 and then times it by this, and then that will give you the whole area. But here I know our trapezium's in the negative side, but it will still work. Okay, so now let's try and do this. So 9 plus that is the same as, well, on a calculator I'm just going to do 9 take away 2.6 equals that divided by 2 equals this, and then times 20 equals 64. So 64 meters. Okay, so this height here after 20 seconds it will be 64 meters. 64 meters. So yeah, just quite surprising that gravity on Pluto is tiny. Well, anyway, yeah. So the answer is 64 meters. Okay.